All right, we are on lesson 4.1. Our goal is that you can use the Pythagorean theorem to solve for a missing side of a right triangle and missing values in a word problem. So first, we have to get a couple terms right. So you can only use the Pythagorean theorem for right triangles. Okay, it only works for right triangles. That's it. You can't do it otherwise. So on this picture, we're going to label a couple of things, the hypotenuse and the legs. So if you can see, legs is plural, hypotenuse is singular. This is the hypotenuse. And these are legs. So you'll notice the legs are the two that make the corner. They're the ones that make the 90-degree angle. Okay, those are the legs. The hypotenuse is across from that. The hypotenuse is labeled as C, and these are all lowercase, which is important. It doesn't seem like it, but it is. And then the legs are A and B. A and B are interchangeable, so you could do either way, AB or AB, doesn't matter. It's just A and B are the legs. The Pythagorean theorem is A squared plus B squared equals C squared. This one here is always alone. Okay, the other two go together. So it says that if you square this number and square this number, it's going to equal that number squared. Okay, so draw a right triangle where A is 7, B is 23, and then use the Pythagorean theorem to find C. Use the information to find the perimeter and the area. So there's really three things we need to find. Find C, find the perimeter, and the area. So C, P, and A. So first we're going to draw a right triangle. A is 7, B is 23, and C is a mystery. So we're going to go ahead and do the hard part first. So this is A and this is B. Doesn't matter which is which, but I'm just going to call it that. The Pythagorean theorem says A squared plus B squared equals C squared. So we have 7 squared plus 23 squared equals C squared. So we get 49 plus, now I got to do 23 squared. So 23 squared means 23 squared is 529 equals C squared. Let's do that. Plus 49 is 578. Now, the last step with the Pythagorean theorem is always square root both sides. Then we figure out what just regular C is. So in the calculator, it's this key right here. It's this little one that looks like a, I don't know, like a check mark kind of. So we're at 24.04. After the 4 comes a 1, so we keep it as 24.04. Now, the perimeter is when you add all of the numbers on the outside. So perimeter is 7 plus 23 plus 24.04. This is our third side. So we get, this is 30, this part's 30, plus 24, it's 54.04. And then the area of a triangle, remember, is base times height divided by 2. And the base and height, remember, again, are the two sides that make a 90-degree angle. So we're going to go 7 times 23 divided by 2. 7 times 23 divided by 2. So we get 80 and a half. And there we go. Next, they want us to draw a right triangle with B is 9 and C is 13. Use the Pythagorean theorem to find A, then the perimeter and the area. So again, these things, except this time it's tricky. They're trying to mess us up. They're giving us C, which is this one. And then B is 9, and then this would be A. We don't know what it is. So start with our Pythagorean theorem. A squared plus 9 squared equals 13 squared. The hypotenuse, this one, is always alone. Always, always, always. So we have A squared plus 81 equals, I know this is 169. I just happen to know that one. Now, to solve for A, we're going to drop our line. Subtract 81, and we get A squared is equal to 88. And again, the last step when you're solving the Pythagorean theorem is to square root both sides, and we get A is about, let's come over here, 88 square rooted is 9.38. The next number is a 0, so it stays 9.38. And then we have to find the perimeter. So perimeter is when you add up all the outside numbers. So 13 plus 9 plus our new side, 9.38. This part's 22 plus 9 is 31.38. And then for area, base times height divided by 2. Again, base and height are the two numbers that make a 90-degree angle. So that would be these two. So we're going to go 9 times 9.38 divided by 2. I got to do that in a calculator. $42.21. And then we're good there. Okay, a couple more. So this one, they say draw a right triangle. Okay. A is 13. C is 24. This time it looks like they're going to ask us to find B because we have A and C. And yep, they do. And then we have to find the perimeter and area. All right. So we'll start with the Pythagorean theorem, which says A squared plus B squared equals C squared. We know A is 13 squared plus B, we don't know, is equal to C squared, so 24 squared. That's a big number. 13 squared is 169 plus B squared, I don't know. And then 24 squared, let's check that. 24 times 24, 576. Wow. Then we drop our line and solve. So minus 169, minus 169. Over here we have B squared equals 407. And then again, the last step when you solve the Pythagorean theorem is always to square root it. So you get B is about square root 20.17. The next number is a 4, so we leave it as 17. If it's 5 or more, it goes up. So this is 20.17. Okay. Next, we got to find our perimeter. Perimeter is adding up the outside, so 13 plus 24 plus 20.17. That is 37 plus 20 is 57.17. And then last is our area. So area is base times height divided by 2. Base and the height are the two that make a 90-degree angle. So it'd be those. 13 times 20.17 cut in half. I got to do that on a calculator. Divided by 2. 131.105. So you see how that's a 5? That's going to make this 131.11. All right, and then we're good there. All right, so then we'll look at a couple word problems and we'll call it good. Okay, so this says a 20-foot ladder leans against a building. I'm really good at drawing, you guys. Hope you're prepared. So there's a building, and there's a ladder that's leaning against it. The bottom of the ladder, so here's the bottom of the ladder, is 5 feet from the base of the wall. So here's the base of the wall. They're telling us that this distance from here to here is 5 feet. And then they're being tricky here, but they told us, so you can kind of see we have a triangle. We have 5, and they want to know this number right here. But then it's like, oh gosh, what the heck? Well, they actually told us that the ladder is 20 feet. So we have 2 out of 3 sides. So we can use the Pythagorean theorem again. So this time, here is our C. And then it doesn't matter which one we replace, but we'll just say a squared plus 5 squared equals 20 squared. A squared plus 25 equals, 2 times 2 is 4, so 20 times 20 is 400. Then we're going to subtract 25. We get a squared is 375. And then again, the last step is always square root. So you get a is about 19.36. The next number is a 4, so it's going to stay 19.36. So that means it's going to go up about 19.36 feet up the wall. All right, last one. So the length of the garage roof on one side is 10 feet. So I'm going to draw a garage. Same as the building. That's all right. The length of the garage roof on one side is 10 feet. So what they're talking about here is this is 10. The length of the rafter, so if you've ever been inside a garage, there's those wooden planks that go down the back of the garage like that when you look up. So what they're saying is the length of the rafter from the edge of the roof to the middle of the garage is 8 feet. How high? So, sorry. How far is it from the rafter to the roof's peak? So this is what they're asking. How far is that? So as you can see, we have a right triangle. This is 10, this is 8, and this is what we're trying to find right here. So we can use the Pythagorean theorem. It's a right triangle, so we're good. A squared plus 8 squared equals 10 squared. This is 64. This is 100. Drop your line. Minus 64, minus 64. And you get a squared equals 36. 100 minus 64 is 36. And then again, last step is always square root. Square root a squared is a. Square root of 36 is 6. So it means it's 6 feet to the peak. Means this height is 6. Okay?